started with this class. Okay, so let's go ahead and get started with a topic that I started with the previous class, which is cisp300, sorry. And it has to do with MIT, oh, okay, not this one yet. We'll start with Scratch. Scratch is a graphical, drag and drop type of programming interface. So for those of you who want to kind of play with actual programming and not just tracing it by hand, this is a really good way to ease into programming. It has got multimedia support. You can write games using it. And when you go to the website, if you just go to scratch.mit.edu instead of info, just go to the home site or the home page. It's kind of like YouTube. In other words, people who have registered can upload their programs onto the website, and even without your own account, you can play with those. Okay. Some games are actually quite impressive. I was just playing a little bit earlier with a little shoot 'em up game here. Okay, like this one. By today's standard, obviously, this game is like, well, why would I even spend time to play with games like this? Okay. Ah, ow, 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 ouch. Yep, yep, yep. But the whole thing, but the thing about this one is, the programming of this thing is actually relatively simple, and the source code is available. Okay. So what you need to do is to register for your own account. Okay. So let me log in first, assuming I can remember, what password I chose. Definitely not a strong password here. Yep, I did. Okay. So I registered. So as a registered user, not only can you play with these games, it's kind of like YouTube, but this is better than YouTube because you can actually download the source code. So right here, I can go to download this project. Okay, so I'm going to say save link as. Put it into my download folder here. And then I can click it to open it. So this is the actual game, and the programming, in terms of pseudocode in this class, it's not pseudocode at all here. It is all written in this kind of program. So you can actually see that it's all completely graphical and with comments too. And each thing that can move on the screen, that you can interact on the screen, is what we call a sprite. Okay, so this entire program is written this way. Okay, it's entirely drag and drop. The only time you have to type something would be only for the numbers, that you have to type in. Okay, everything else is drag and drop. You cannot make a syntax error because there's no syntax in this case. If a particular block does not belong to a certain place, it simply won't let you drop into that place. Okay. And the shape of the objects or the shape of the blocks tells you, where they can go into, because some have notches and some have specific shapes, and that's really I think it's a very good way to ease into programming. Are there any questions about this kind of programming platform? I would say it's related to this class, but it's not required for this class. Okay, so for people who want to just kind of do some practice, with your programming, your skills and whatnot, this is not a bad place to start. But you can look at this as, well, it's kind of fun and kind of interesting, but it's not really going to be very useful because, well, when I'm done with these games, I can upload it to the Scratch website and let other people play with it. What else can I do with Scratch or something that looks like this? Okay, two things. In the previous class, I was already looking into this. One has to do with the Raspberry Pi. So if you look up Scratch and Raspberry Pi, you can see there are projects out there to import Scratch to deal with Raspberry Pi. So we heard so that's coming. Okay, I think it's being actively developed right now. Does anyone know what is a Raspberry Pi? Go ahead.
It's a project done, I think, by MIT or Yale to create the least expensive computer ever for $35.
Yep. $35. What does $35 buy you?
Buys you I think it's a single core processor, an HDMI output, a VGA output,
USB.
USB, and an SD card.
Yep. And you can run Linux.
Yeah, that works well.
Yep.
They're also working on the student teacher version, I believe, that should be released
Okay.
as well.
All right. So what can you use something like that for? I mean, it's a very inexpensive computer, but it's infinitely pointless if you cannot do anything useful.
You can
Robotics.
Yeah, well, that's what I was saying. They use it in robotics a lot.
Mm-hmm.
You can run XBMC Media Center on it and stream 1080p to TV.
All right. So you can make your own multimedia device out of it.
Home automation or some other kind of sensory detection.
I believe it also has an Ethernet capability built into it, so it's already network capable to begin with. So because you can run Linux on it, and it has Ethernet already built into it, and it has USB ports too, you can very easily turn it into a web server. Okay, so you can have a micro Linux server that is up to you to program, in PHP or Perl or whatever language that is already included or supported by Linux. Yep.
You think we could like run Wheels on it or something like Twitter has eventually? Because I know I've seen hook up a few of them to make a small supercomputer.
You can definitely hook it up as a supercomputer because if your kernel supports clustering, then it is already supported. Because Linux has special versions to support clustering, so that means you can use the same kernel on a networked bunch of these little things. Then you can have your cluster computing using the pies. Yeah.
Like that.
Yeah.
That'd be great for like a PLC for process control.
Yeah, PLC stands for Programmable Logic Controller. It is used a lot in factories, manufacturing and other types of processes where automation can be used to make things smoother, like a nuclear plant. Okay, and that's how the Iranian nuclear plant got hacked. Was the Stuxnet virus had a payload not only to infect and change the behavior of the computer, the PC, the Windows computer that it was infecting, but the payload was specifically programmed to find what type of PLCs are being used and go change the code on the PLCs themselves. Okay. Now you have to understand, in a nuclear plant, the PCs are not really that useful. In other words, someone can go into the control room of a nuclear plant, and basically machine gun down, blow up all the PCs, and the nuclear plant will still be operating without any problems. Okay, because the PCs are acting more like a terminal. Okay, if you want to find out what is going on on the factory, yes, you use a PC and you go to a particular PLC and say, oh, okay, this is the status of this particular equipment. But the PC doesn't really do anything other than that. Okay, it can also be used to update the firmware or the software on the PLCs. But once the software is already uploaded, the PLCs are completely standalone, independent to the PCs. Okay, so the Iranian nuclear plant was infected by Stuxnet, and the payload of Stuxnet actually contains specific code and software to upload to the PLCs. And it's not just to wipe the PLCs so they have no programming whatsoever. It was particularly specifically designed to change the speed of the centrifuge part of the equipment in a certain way that is very subtle. It speeds up and slows down very rapidly, but it is not observable from the outside. But it does damage the parts on the centrifuge, and that's basically one of the last refining process to get refined uranium or plutonium. Okay, so they ended up having to replace a lot of that type of expensive equipment because they were all getting damaged in the same way because the PLCs were reprogrammed. So that was one really sophisticated malware in terms of in the history of malware. I think that one was basically still the top. Okay, that's it. Do you guys know about that? Stuxnet? No? Okay, you might want to read about it because it's kind of interesting from the technical standpoint. Yep.
Question about Scratch.
Yep.
The program. If you create a game or a program there, and you want to send it to a friend, can you send them the link, or can you send them just that program? Can it run independently?
You got two ways to do it. You can send them a link to that project on scratch.mit.edu, you can also send them the SE file, the Scratch program itself.
So if
But then
you
they
run
will
it
have to
again-
install Scratch to run it. But Scratch is free, and it doesn't take up that much space, so it's a non-issue. Okay, so that's one thing. Raspberry Pi is also very interesting because you can put it into basically robotic stuff. Okay, if you have a larger remote control airplane, you can put it on a remote control airplane and turn it into a UAV, and an autonomous UAV too. Now you have to check with your local law enforcement and federal laws to make sure that you do not violate any laws in the process. But technically speaking, yes, you can do it.
Was that the disclaimer for the video?
Huh?
Was that the disclaimer for the video?
Yeah, I will probably have to start with that disclaimer for just about anything that I talk about. And that's the beauty, or that's the trick of the DMCA. Does anyone know what is the DMCA? It's one thing that you will eventually run into one way or another. Not only because you're interested in media, okay, this is my CD, how come I cannot back it up? Or this is my DVD, how come I cannot back it up? Not only from that standpoint, but at some point as a developer, as a programmer, as someone who deals with code, okay, maybe that's not even your occupation. You just have to do some degrees of programming just to get something done. Yep, go ahead.
Additional Millennium copyrights that. It's the Additional Millennium copyrights that. It's the Copyright Act that basically governs how everything in the digital
Right.
sphere is used.
Right, but the DMCA, is very, insidious in a way, because if you just look into and tell people something about the copy protection mechanism of something, you're already in trouble. You don't have to do it. Okay, the people that you tell it to don't have to do it. Just by distributing that information, or just the act of looking into it, is already illegal.
That's why you have the GNU and the CC license.
Yeah, you have to basically buy a little island to make sure that you can do it. So that's the Raspberry Pi, which is something that I think will be useful, very interesting, very useful. And for those of you who want to look into robotics, when you are going into a 4-year university, this will be definitely one thing that you have to look into. The other thing that is also interesting that is related to Scratch is how many people want to write apps for cell phones and tablets and other mobile devices and stuff. Okay. Well, maybe you have not thought about an application yet at this point, but once you have the ability to do it, I'm pretty sure 80–90% of the people can say, oh, you know what, I just want to do this one little thing with my phone so they can do blah, blah, blah. Okay, there's always that one little thing that you can do, right? Well, as it turns out, MIT has another tool for that. It is called the App Inventor. So you go to appinventor.mit.edu. I believe this is still in beta stage, okay? But it has the same feel and look as Scratch. So once you know how to deal with Scratch, do with the Scratch programming, you can kind of move on to the App Inventor, and then you can start to write apps that can actually be packaged into the APK file, and then you can install the apps on your own cell phone. It doesn't actually need to run with App Inventor itself. Yep.
That's just for the Android-based.
It is Android only, because Apple probably would refuse to open up their development environment for free.
Yeah, the only way you can program apps for Apple products is to get the SDK from Apple. So.
Right. I actually talked to the director of the media center, who's actually in charge of this project. She was one of the speakers for one of the conferences that I went to over the winter break. And she basically said they would like the App Inventor to be available to all mobile platforms, trying to get past Apple is going to be the major hurdle. It's not a technical issue; it's more of an issue with Apple itself, trying to control their app eco-structure or ecosystem.
Dictatorship.
Dictatorship, yeah, that's one way to put it.
I kind of understand though why Apple does it, because if they are going to when they try to release a new product, they're super secretive. They don't even release it to a beta outside the company, and so I understand from that standpoint why they don't want to do it, but I do still think it's dumb.
Well, that means, if you want to play with App Inventor and you only have an iOS device, then you have to buy an Android device to do it, which doesn't cost a lot of money.
Well, I'm buying a transformer tablet.
Or you can run it in a simulator. This will work well in a simulator as well. In other words, you don't need an actual Android device to do it. If you download the app, and also the package, it will install what we call an emulator. Then you can emulate a Android device on the PC, and you can actually run programs in the emulated device. At a very low speed, it's really kind of slow, but you can do it. Okay, that way it doesn't cost you a single penny. Yep.
Does the emulator only access one single core or something?
Yeah, it's single core, and it has an older version of Android installed, and but it will work. I mean, if you just want a proof of concept, that will work. Okay, so I just want to point out these little things that many of you may have thought about and may be interested in. I'm teaching cisp300, which is app development, basically app development 1 in fall 2013, basically next semester. So if you're interested, you should probably sign up for that class. Yep.
When you said 362, you mean like 362, not 360 as well, right?
362, that is correct.
Okay, I was just making sure. I was like, wait, I thought.
And you do not need 360 for 362,
Alright.
because I'm going to use this as the main tool for that class. So that way we can basically bypass all the Java related stuff, syntax and classes and stuff like that, and we can go straight to programming. Yep. All right, so just little resources, not directly related to this class. I was looking at Moonwalker too because I was trying to make Scratch the character do the moonwalk. And then we have Code Academy. Right.
Were you able to get Scratch to do the moonwalk? Were you able to get him to do the moonwalk?
Yeah, you just have to make it walk, but move the sprite backwards. And then MGM or some other media company will sue me for copyright infringement.
We're not gonna get much.
And you
Huh?
go to Universal Music. 2001 Music.
So, over the weekend, I actually found a site where you can get like MP3 files that are open, like basically Creative Commons. You can use them in any of your games. It's actually through Newgrounds, their audio portal. All the music that's on there is free use with attribution. So as long as you tell this artist made this music, you can use it.
That can be useful.
Yeah, it's a great site.
All right. Now I did finish grading exam 1. So exam 1 is now graded. You won't see any entry here because it is just in your grade book. How many people have looked into the grade book and found your exam 1 graded? Okay. So for each question, there are multiple items, there are multiple outcomes, and then for each outcome, you will get a score, and then the combination of all the outcomes will become the score of a particular question, and there are 4 questions, each one has equal value in the exam, and you add up all those, that becomes the score of your exam 1. I did not have time to basically do a plot of the bell curve, but it was kind of interesting. It's a full spectrum bell curve, which means I got everything from close to 0, and a few people got 100%. So I would say it's a bell curve, but it does skew to the the high end, the 100% side. So go ahead and take a look at Moodle. Go to Moodle, go to grades, and you'll be able to see your own grade. Look up exam 1 or X1. That's what exam 1, and your score should be there.
Does the mobile theme support that? Does the mobile theme support
I
that?
do not know.
Yeah.
It does? Okay. Isn't that great, having a mobile theme? So this way, you don't need a little point, to click something on your
Some of them are
cell phone.
terrible though.
Some?
of the mobile themes, like
Really?
Like, I don't know. I don't like them as much. Like if the D2L one, I don't like it. I just
Oh.
go to desktop. Same with like Newegg and Amazon. I just go to the desktop version. I'm so much more used to it.
D2L is terrible.
Well, D2L, even with a regular computer, if your screen is not big enough, it's still terrible because they will give you a frame within a frame within a frame, and then you end up with like 3 layers of horizontal scroll bars. Yep. All right, so we are pretty much done with top-down design. There are only like a few more topics that I want to go over, so we will just kind of go over those things here. All right, so factoring is already done. We have done all that part already. So what I want to do is to talk about something that is not quote-unquote technical, but it is very important because even though top-down design is touted as, this is the way we should do things, but in reality, a lot of times that's not how things are actually done. When you write programs, especially when you're writing an algorithm that is new, that you're not just copying from some other place, you are refining the algorithm like the way I do it in the class, right? You start with something that is just the overview of what you want to do. Okay, we know this is a loop, and this is the condition to get out of the loop, and then you try to specify more and more and more details, right? At some point, you will end up with something that is a little bit bigger than what you thought would be manageable. Okay, so eventually your algorithm will be 20 lines, 30 lines, 40 lines, and then 50 lines, and at some point it will be out of hand because you can't really keep track of all of those constructs at the same time. So the question is, what do we do in that situation? Okay. Top-down design is good. We talked about it. So I'll just click that link here. Okay, think in big steps basically. When you're actually writing programs, depending on the nature of the program, some people write programs from the bottom up. In other words, they try to figure out what is the lowest level of things that I need to do. Okay, and then they build those things first. And then once they have the basic building blocks, they build other building blocks on top of that. So you basically start with the smallest possible unit, okay? And then you build, once you test those small units, then you build bigger units out of those things, and then bigger units, and then bigger units, okay? Bottom up has one really big advantage, testing, okay? Because you're building from the ground up, you can always test the simpler logic first to make sure they're working. And once those are working, then you can build bigger blocks and then test the bigger blocks. And then you can build even bigger blocks and test those bigger blocks. So that's bottom up. And then the last slide talks about abstraction. Abstraction is basically looking at a long algorithm. And then what you want to do is to figure out, okay, how can I extract one part of the algorithm out of the huge algorithm itself and turn it into a quote-unquote sub-algorithm, basically a subroutine. Okay, so this is really giving me or giving us the entire class a preview of what is coming. Because when we talk about subroutines, one of the purposes of subroutines is to do abstraction so that your code is easier to write, easier to read and understand. Okay. So that's all kind of fuzzy stuff. It's not really technical, but it is important nonetheless. So after this, okay, after we are done with top-down design, we are now, I'm just turning on editing so I can highlight the topic that we are in at this point. That will be topic number 7. So we are starting to talk about arrays. I'll turn editing back off because it gives me all kinds of little icons that can be distracting. There we go. Arrays. And it only has one single module, which doesn't seem to be, well, what is the big deal about arrays? Before we talk about what arrays are, let's think about life without arrays, which is what we are at this point. We talked about variables, right? Okay, we talked about conditional statements, we talked about loops, we talked about a lot of the other constructs. Can you still remember how to find the maximum of 2 variables? Okay, we use that example a lot, right? So you know how to do that. How about finding the maximum of 3 variables using a similar approach? Yeah, we talked about that too. Okay, when we talked about multi-branch conditional statement, that was the code that I was using to illustrate multi-branch conditional statement, which basically has the else-if construct. But using a similar concept, we can do it to 4 variables, right? Okay. Yep.
We're still trying. So you're talking about finding the highest variables, right?
We are trying to find the maximum of a collection of variables. So instead of just talking about it, I'll just give you the visual. Okay, it'll give you the actual code of finding 3 variables, the maximum of 3. Okay, if I have 3, I start with w. So if w is greater than or equal to x, and w is greater than or equal to y, then the maximum, which I call z, will get the value of w. Else if I can confirm that x is the maximum, which means x is greater than or equal to y, and x is greater than or equal to w, then x is the maximum. Now, if these two conditions are both false, that means the third variable, which in this case is y, has to be the maximum. I don't even need to do any test, and that's the algorithm that we can use to find the maximum of 3 variables and put that into Z. Is that okay so far? Does it kind of give you a little? Okay, so you guys all remember, to a certain point of this particular algorithm. I can change this a little bit to handle 4 variables, right? Because with 4 variables, if I use the copy and paste approach, copy and paste, we just have one more variable to confirm. So we have, v in this case. So you have to say v is greater than or equal to w, and v is greater than or equal to x, and v is greater than or equal to y. Then v is the maximum of the 3, and you can adjust the other statements accordingly. But you have to add one more branch because now you have 4 variables. Each one can be the maximum, so you have to increase the number of branches by 1. Are we still doing okay so far with this discussion? Can you use the same approach to write a code for 5 variables? Sure. I mean, it's basically the same thing. You add one more condition on each line, and you add one more branch, and you're done. Okay. What about 10? Well, we can extend the approach. If I can do 5, I can do 6, and so on. Okay. The problem is, what do you think the code would look like? Let's say I want to find out who on this campus has the highest GPA. What is the enrollment of ARC? Yeah, but let's just say that I have one variable per student, okay? How many students do we have on at ARC?
Let's say we have about 40,000.
It's 30-something thousand, but yes, the order of magnitude is correct. 30-something thousand. Now that is not the problem, okay? Having 30,000 variables floating around is not the main issue here. The main issue is, what if I just add one more student? What would happen to my program? Go ahead.
You'd have to rewrite every line to add to what we just did for that one student.
Exactly. So this is what we call a brittle or very rigid program. Okay, it can only serve one purpose. Okay, if you change just one little thing about it, you have to make massive changes to the entire program just to accommodate for that one little modification.
What's the analogous, the analog for brittle? What's the opposite of that? What's a good code? What would
Arrays. That's why we are talking about it, because I want to show you, why using individual variables is useful, but we will run into problems if we just use individual variables. Okay.
What is it when you talk about code that works together well with like modularly or modularly? You got terms.
Oh, flexible.
That's what I'm asking.
Okay, general. Okay, they're just more general. You can make changes or change the size of a problem without changing the code itself. Okay. All right. So what if I tell you that this little program, without explaining the notation at this point, so what if I tell you this is the notation? Just bear with me here. I'm just going to finish the program, and we will come back to this one. Okay, so this is the program that will work for 30,000 students, 30,001 students, 40,000 students, 50,000 students. It's the same code. What if I tell you this, this is the option? Would that be a little bit better than the approach that we were talking about earlier, where you end up with whatever number of students you have times 2 plus 1 lines of code, and then every time you want to add one more student, You have to change, that number of lines plus, 2 more lines to it. Okay, this is a lot more universal, and this is what you can do with arrays. Okay, and that's why we want to talk about arrays in this class, is because we can actually make algorithms very general and can work with problems of different sizes without actually making the program sensitive to the size itself. Okay. Do we have any questions at this point about the rationale of having arrays, or the problems that we can run into if we do not use arrays? That part is okay? All right. So now let's talk about arrays. An array is a box. Okay. If you look at a individual variable as a container, kind of like my water bottle, an array is basically a box of water bottles or coffee mugs or whatever container you want to use. The reason why I use a container like this, as a variable, is because the content level or the liquid level inside the container can be different. Okay, so I can have one empty coffee mug, one that is half filled, and then the next one is a quarter. The next one has 70% filled, and so on and so forth. They can all have independent values in it. Okay, so for this part, I'm just going to draw a picture. This is the very few time where a picture is useful. So instead of individual coffee mugs, we have boxes. An array is a box. An array has a name too, just like any variable. An array has a name, so in this case, I would call this array, A for array. And let's say it has 3 boxes inside. So it has 3 containers in the inside, so they have these 3 containers. Now, normally, when we deal with individual variables, which are also containers, the variable itself has a name. Okay, so I can name this one W, I can name the next one, X, Y, Z, and so on. But in this case, because the box itself has a name already, the coffee mugs or the containers inside the box, they do not have names. Okay. Now, this is the really, really useful part. Is instead of names, each one is now numbered. Within a box, the containers are numbered but not named. And the numbering is always starting with 0, 1, 2. If you have more containers, it will be 3, 4, 5, and so on and so forth. Are we doing okay so far with the concept of an array? Go ahead.
We'll see if you said that the containers aren't named inside the box array, but wouldn't the numbers themselves be names?
They're called indexes. They're not names. Okay, so I guess in programming, the word name is the same as what we call an identifier. They're all symbolic. Okay, you use the lowercase, uppercase letters, and the underscore for names. But these are all numbers. They're all like 0, 1, 2, 3, and so on. Okay, now that part is very, very important. Okay, so instead of saying I want the coffee mug or the container called W, now you have to say, oh, I want coffee mug 1 inside box A. Okay, because you can have other boxes too, right? Because you can have a box called B with its own containers. Okay, so I'm just going to draw this as an example. So we have another box. This is called B, and then inside we have, let's say, 4 containers in this case. 1, 2, 3, 4. With 4 individual containers inside the box, they will be numbered 0, 1, 2, 3. So now we actually have on this, in this picture, we have 1, 2, 3, 4, 5, 6, 7, 8, 9. We have 9 containers. But to pick out a particular container, like this one here, it is now, we can say this is in box B, and it is number 2. Are we doing okay so far? Okay. And the notation to say which part is the name of the box and which one is the number inside the box is to use the square bracket. So if you have a B outside, that means that's the name of the box. I guess you can use the square bracket to kind of say, oh, okay, that's the box, right? So inside the box, we want the container that has a number of 2, and that will specify an individual item inside the box. Are we doing okay so far? Okay. Whereas in this case, we just have X that is the name of the individual container, and that's it. Now, once you know how to address, or once you know how to specify a container inside the box, it behaves exactly the same way as any container. In other words, you can use this as the left-hand side of an assignment statement. You can use it for comparison. You can use it in multiplication, subtraction, anything that you can do with this kind of container. You can do it with this container. It's just that its name is kind of funky because you have to name the box first and then the number of the item in the box.
Now, can you have like tiered boxes? So can you have a box and then a sub box full of sub-containers?
Yes, you can have a box of a box of a box of a box. And it's really the same way, this part I won't test people with this, with this, the concept of an embedded array, or nested levels of an array. But it's a very useful concept because in this case, what you're describing is something that looks like this. This black pen is actually running out of ink. We'll try this one. Okay, so what you're describing is something that looks like this. You have a bigger box that contains smaller boxes. Let's say we just have 3 of the smaller boxes here. These 3 little boxes are inside, a bigger box like that. Okay. Now that's a good question. How do we deal with cases like this? Because then we can still have, each small box can still have, individual items. Let's say we only have 2 in this case, so 2 containers.
Now would it be like, box or larger box alpha with box A, B, C, and then with 1, 2, 3, 1, 2, 3, 1, 2, 3.
It's all numbers. Okay. Only the outermost thing has a name. Everything inside are numbered. Okay. So but that's a very good thing to bring up because in this case, I can say that the outer box, which is the largest box, has a name. Okay. It can be C, it can be big box, it can be whatever name you want to call it. Yep.
What are we calling the name of the array? Is that an array name? What do we technically call it? An identifier?
It's called a multi-dimensional array. Because this is called a single-dimensional array, and this is called a two-dimensional array. But you can apply this concept to even bigger boxes that contain even more boxes in the inside. Okay, so in this case, this entire box, the big box, is called C. Okay, so if I wanted, this entire thing is C. Because this is what is exposed to the program. Only the outermost part is exposed to the program that needs a name to identify it. Now, everything inside the biggest box can use numbers already. In other words, this box here is number 0, this box is number 1, and this box is number 2.
And it has to be numbers inside the box.
Correct.
Okay.
And then everything inside the smaller boxes are also numbered. So in this case, we have 0 and 1, 0 and 1, and 0 and 1. So within a box, you always start numbering from 0, and then run up to the number of items minus 1, because 0 takes up 1 spot already.
So what's the syntax? Yeah, what's the syntax to pull like 0 from the sub-container or the
Well,
sub-array?
that's also a very good question, because we can apply what we have just learned, exactly the same way. Okay? So let's say we are not interested in individual containers. Okay, we're just interested in this entire box. How do I name that entire box? This entire box is C bracket 1, because it's item 1 inside the entire container C. Does that make sense? Okay. So even though it is not a single container, which means C bracket 1 in this case cannot be used for comparison. Okay, I cannot use it on the left-hand side of an assignment because it's not a single value. Okay, but nonetheless it has a name. Yep.
Could that be similar to like a set?
No, it is not a set because everything is ordered. Okay, in a set, things are not ordered. Yep.
So can you declare that the boxes inside the big box have names, and then you just tell the program that this is now?
Later on, we'll have the concept called a record or a structure. So that is where the inside thing can have names. But in the case of arrays, everything is numbered except for the outermost, the biggest box.
Well, if you were gonna talk about the same box somewhere else in the program, and you would just call it into another array, which is the big box, right? How would you go about renaming the previous box out there, like C1? If you're talking about about C1 somewhere else previous to the big box array, and it becomes C1 after that array?
Okay, now that's a big question. How can it become something else? So you have to create, if you have another box here, and you want that box to eventually become a component of this box, you need an assignment statement of some sort to turn the other box into a component of this bigger box. Okay. So that's kind of beyond the scope of this class is how do we dynamically change the boxes so they can dynamically say, oh, I want to include this box into this box too. Yep.
They got this trying to, I don't know, it sounds like just like instead of boxes, really just like a filing system.
It's kind of like that. Yeah, it is kind of like that. So let me just kind of finish this topic first. So how do I name, let's say this little container here, individual container. It is in the largest box is called C, okay, because the name C is exposed to the programmer. Inside the big box, it is in little box number 2. So C bracket 2 refers to the smallest box, the smaller box, which in this case is the one at the top. But inside that box, I have 2 containers, and I just want the container that is numbered 1. So I apply the concept again. Okay, so this is how you can apply the same concept, except in a nested or structured way, so that you can have any number of levels of nesting of boxes, and still be able to address to each individual item. Yep.
So the bracket indicates a step down, like in sequence. So C is the variable that the program can see. Then the bracket would be like the first bracket would be whatever container inside the array.
Yeah,
and
each
then the next bracket would be
exactly
the inside the container.
The square bracket is called an indexing operator, which basically means it can only be applied to a box. So in this case, C has to be a box because I'm applying bracket 2 to C. But at the same time, C bracket 2 itself also has to be a box because I'm applying bracket 1 to that thing. Now, when you look at this entire thing, C bracket 2 bracket 1, I can no longer apply the bracket operator because I'm down to a single individual container at that point, and you cannot index a single container. Yep.
I thought the 1 would be wrapped inside the bracket of the 2, since in the picture the container 1 is inside box 2. Could it be C?
That's why you apply that last.
Sorry?
That's why you apply that last. Because when we read this, we are reading from left to right. So you have to start with the largest thing first, which is the entire big box C. Now inside big box C, we have little box number 2. Inside little box number 2, we have container number 1. And that's why it is specified as C, open bracket 2, close bracket, open bracket 1, close bracket. Yep.
Can you give us a clue what that might look like in C?
That's exactly what it looks like in C.
Exactly. Is there no dot in between, right? There's
Sorry?
No dot in between?
There are no dots in between, there are no commas, that's exactly the syntax in C. Because this class is a prep class for the C class, so I try to stick with syntax with C whenever it is not confusing. All right. Do we have any questions? No questions? Okay, so let's go back to, in this case, in this little original picture here. In fact, this time I can start to use the notepad here. So everything will now be captured again. If you want to take a picture of the whiteboard, that's fine with me. You can send a picture to me and I can upload it to the website too. Okay, so getting back to this point, I keep forgetting to bring my little webcam because with the webcam I can just take a picture and have the webcam display on screen, then it'll be screen recorded, and I don't have to do anything. I have the webcam, I just don't have the cable to use it. No, I forgot to bring my webcam. All right, so getting back to this part here. So let's say we have a program that looks like this. X is a regular type of variable. It is all by itself. It has a value of 1. And do you think I can do something like this? Assuming there's an array called B, called A, and it has that particular item. As it turns out, the most flexible part of using arrays is inside a square bracket. It only has to be a number. and that number has to be within the right range. That is all to it. Okay, so before we talk any further, let's talk about the indexing of the items inside the box. If you have 3 items inside the box, what is the valid range of the number between the square brackets? 0 to 2, which is the number of items minus 1. If you have 4 items, it goes from 0 to 3 and so on. Okay, so that defines the valid range of values of things that can that one single value that is between the square brackets. Okay, so that means I keep trying to do it on the whiteboard, but I should be doing it over here. Okay, so this is actually fine. Okay, so that means whatever is inside the square bracket can be a number, a literal number, can be a variable, used in a kind of complicated expression. As long as this expression ends up with a value that is within the right range, it is still okay. Are we doing okay so far? Yep.
It's when you're updating it, you're just updating it to the value of the container, or?
You are updating the container. X times 2 plus 1 in this case is only specifying which container within the box you're trying to change to 2 in this case. Okay? Okay?
Right.
Now this is a big step, okay? In fact, this is a major contribution by using arrays, because before, if you want to access a particular container, you always have to name it, right? V, W, X, Y, Z, and so on. But in this case, you can identify an individual container using a number. And that number can be controlled by other variables. Are we doing okay so far with this concept? Okay. There's only one more notation we need to talk about, which is the bar notation, which is only used in this class. Don't try to use it in other classes. The bar notation like this, bar A bar, is the number of items in an array. I use the bar, because it is kind of like the, when you do measurement, it's kind of like, the measurement, symbol to size up, a particular item, and that's why I use the bar notation. So in this case, it's definitely not the absolute value of something. It is just telling you the number of items inside an array, and it can only be applied to an array. If A is an individual variable, bar, does not make any sense. Are we doing okay so far with the notation? There are only 2 additional notations. One is the square bracket notation, which basically says, oh, okay, I can see that this is a box, so which item in the box do we want to access? And it has to be a valid number within a certain range within the square brackets. The bar notation is only used to specify the size of an array, because that can come in handy sometimes. So let's go ahead and run a program through our usual mechanism using a spreadsheet. So we're dealing with the first program dealing with arrays. It's not the one that's going to find the maximum, because that's actually a little bit complicated. I just want to make it something that's very simple so that we can just focus on the concept. So we start, since I'm not using my usual user account, it doesn't keep my settings. So just do this again, turn off all of the options. I do want to use a replacement table. Thank you. It still won't let me use I, because I is a special item inside the replacement table. Go to autocorrect. So I have to go to the replacement table, look up I. Apparently, a lot of people type I with a lowercase when they mean I with an uppercase, and that's why there's a replacement entry here. So we just have to delete it, and now we're good to go. Okay, so rectify this a little bit. Okay, I get 0, while I is less than bar A bar do. A bracket I gets I gets I plus 1, and Y. here. All right, so this is our program. We want to trace it. Now, when you trace this program, you have to know ahead of time what is the size of array A, because otherwise you cannot know when to stop. So when we look at the trace using a new window, we have to be a little bit careful down because we have to specify the actual size of the array. Okay, so we have the usual stuff, comments, because we have a condition to evaluate for the loop. We got line number. We have a regular variable I, which is kind of typical stuff, and then we have array A. So let's just make an assumption that we have 3 elements in A. So each item inside an array is called an element. Okay, so we have 3 elements in this case in array A. And in this class, I just use bracket 0, bracket 1, and bracket 2 to indicate that these are elements within the same array. And I just merge these columns so that they look better, so that you can see that A refers to all 3 columns, but each one has its own value. So are we doing okay so far with the setup of the columns? Now this is already important because you can see that each each element of the array has its own column. And that is because each one is a container all by itself. It can contain its own value that is independent to the values of the other items of the same array. Are we still doing okay so far with this example? Okay, just the setup of the columns. I is nothing really special nothing special about I. So at the beginning of this program, I can make everything unknown. Okay, so as a precondition, I'm just saying that, well, let's pretend that we know nothing about anything because everything is going to be initialized in this program. Now we are ready to execute the program. Starting on line 1. Line 1 is not really that complicated. We already know what this is going to do. I as a variable will get changed to a value of 0. Then we move on to line 2. Line 2 gets a little bit interesting because this is the first time we actually apply the bar operation. Bar A bar, once again, is the number of items in array A. How many items do we have in array A?
3.
We got 3, and I has a value of 0 at this point. 0 is less than 3 is true. Okay, very good. So we have to go into the loop onto line 3. Now line 3 is really kind of the important part of this entire program because what it is going to do depends on the value of I when I execute line 3. Okay, now that is the important part. Okay, because the first iteration doesn't really show that. Okay, but in the second and the third iteration, you will start to see and go, oh, okay, so the same line can refer to different things depending on the value of I. Yep.
So in this case, A bracket 0 is getting a value of 0.
Correct.
And then I is being incremented by 1 after on line 4.
Exactly. Okay. So, but just to do it, step by step again, repeating what you just said, the left-hand side of this assignment statement, which is A bracket I, is going to use the current value of I to indicate which item in the array I want to access. Okay. At this point, I has a value of 0. So A bracket I is referring to A bracket 0. A bracket 0, according to the columns, is just column D. So column D is the one that I want to change because it is the left-hand side of the assignment. The right-hand side of the assignment is really simple. It is just I by itself. I has a value of 0, and as a result, column D at this point is going to be changed to 0. Okay. Are there any questions about this? No questions? Okay. And then on line 4 is a very typical increment type of assignment. We are just adding 1 to I. I had a value of 0. Now it's going to be incremented to 1. Then we have to go back to the beginning of the loop on line 2. And I now has a value of 1. Bar A bar is still 3 because we are not changing the size of the array. So 1 is less than 3 is still true. We have to go back onto line 3. Now this is the important part, okay? If I have to identify really key moments of a class, this is one of those. Because line 3 has not changed. Okay, if you look at line 3, it is still the same thing. What has changed is the value of I. Okay, and because we use the current value of I to indicate which item we want to access inside array A, this time we're accessing something different because I has changed. So when you look at this, the left-hand side of the assignment, which is A bracket I, has now changed from the first iteration because I has a value of 1. So A bracket I is the same as A bracket 1. And A bracket 1 is column E in this case. So it is column E that is getting changed. The right-hand side is just I by itself, and I has a value of 1 at this point. So that means column E is now updated to a value of 1. And if you want, as I said a little bit earlier, if I have to identify key moments, this is the key moment because this is why arrays are so useful. It has to do with the fact that you can stick any expression inside a square bracket. Okay? In other words, which element inside the array you want to access can depend on an expression. And the expression can change the value over different iterations of a loop. Yep.
So, what if, well, obviously the program is great, but what if you gave us something where
It's out of range?
Yeah, it's out of range.
We'll talk about it. Okay, that's a very good question, and we'll definitely cover that. But we'll go over the proper use first, and then we'll say, but what if I is exceeding the valid range and the program is specified that way? What is going to happen? Okay, so we'll talk about that. Okay, so now we can go to line 4. Line 4 is simple. It just adds 1 to I. Yep, question?
Yeah. In the array A, on line 4, which says I plus 1, that plus 1 is shifting the array A from 0 to 1.
No, it is not shifting the array. It is just changing a regular variable, in this case I, so that I is now 1 more than what it used to be. It doesn't, I is just a regular variable. It's not any different from W, X, and all the other variables that we have talked about. It is how we use I inside A bracket I that makes it kind of special. But I is normal. I is just a normal variable, nothing different from all the other variables that we have used before. In other words, I has no direct tie to array A whatsoever. Yep, go ahead.
I was just saying it could be X or Y or.
Exactly. And if you want to hop, from element to element, you can say I times 2 inside the square bracket.
Wait, say that again?
Instead of using I, you can say I times 2 inside the square bracket. So that will make it initialize every other variable instead of every variable. As I said a little bit earlier, what you have inside the square bracket can be any expression that gives you an integer that is within the correct range. So you can use, all sorts of stuff to do that. Okay.
It's the expression that's doing the changing.
Right, because the expression in this case changes as we change the variable I, and that makes the program very useful. So after line 4, we go back to line 2. Line 2 is evaluating the same condition. I is now 2. 2 is less than 3 is still true. So we go through one more iteration. On line 3 this time, I has a value of 2. So when we access A bracket I, we are actually accessing A bracket 2, which is on column F. The right-hand side of the assignment has I. I has a value of 2. So that's why column F is the one that is updated to a value of 2. On line 4, we add 1 to I again. I goes from 2 to 3. We go back to line 2. I is now 3. Bar A bar is 3 as well. 3 is less than 3 is false. We are now done. Post, and that's the execution of this entire algorithm. Do we have any questions about this algorithm? No? Go ahead.
I understand you gave us an array of 0 through 2 for simplicity, but what if we had like 100 or 1,000 or 10,000?
It's the same approach. Your trace will just get longer.
So in an array, would you use a substitute rule or forget rule? Does it infer to the other side when you have an algorithm like that?
In terms of the pre and post conditions, it gets a lot more tricky because to express the state and the relationship between all the variables, in this case, a bracket 0 is its own entry, a bracket 1 is its own entry, and then a bracket 2 is also its own entry. So in this program, as we go through the iterations, then you will be using the forget rule just like before, but a bracket 0 has nothing to do with a bracket 1. A bracket 1 has nothing to do with a bracket 2. So that's basically means that you will be adding a bracket 0 equals 0 first, and then the second iteration you'll be adding a bracket 1 equals 1 without forgetting what you already knew about a bracket 0, because they are individual containers. And as a result, the forget rule does not apply, does not forget what you knew already of another element in the same box. That's a good question. And there was another hint, I think. Yeah?
We did learn that too already. We used the forget rule and we didn't forget anything actually.
Correct. In this case, the only thing that can, in this particular program, the only time you will be, there's nothing to forget in this case. They're all substitution except for the line 1, because line 1 does change something. Line 3 is a forget rule, but the result of the forget rule does not lose anything, because each time we run line 3, it is doing something to a different individual variable.
4 is a substitution.
Yeah, 4 is just a substitution. And I'll leave it up to you guys to determine what is the loop invariant. Because the loop invariant in this case is a little bit more complicated, because in addition to saying something about I, we can also now say something about the elements of I. But we don't have the tool in this class to state for all blah blah blah, a bracket blah 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 equals blah. Okay, so that's why I kind of hesitate. I don't want to talk about the loop invariant in this case, because we lack the tool in logic to specify that in this class.
What's the tool?
It's the for all operator.
For all.
For all. Yeah, which in mathematics it looks like a but inverted.
Oh, yeah.
This symbol here. So in order to state the loop invariant, I need something like this, because I have to say for all I, or for, I cannot use I again because I is already a variable. So I have to say, for all, k, whatever, and k has to be from inside a set, going from 0 to the current value of I. Then you can say something about a bracket I or a bracket k equals k. So that's the kind of tool that we need to specify the loop invariant. But since we haven't really talked about the for all operator or element of the set in this case, so I don't want to touch on that yet. Okay, you will see all this stuff in cisp 440. People who like math will really like cisp 440. People who do not like math in this class, if pre and post conditions kind of bother you, 440, by the time you get to 440, hopefully you have all the tools that you need, because you have taken all the math classes, calculus and stuff like that, to handle the math in that class. But math is really important in programming. That's really the truth is it is important. Okay, so getting back to this program, that's the end of the execution of this program. So we'll just go ahead and save it, put it into a folder, and I have to be careful because I'm not using my persistent drive the way it should be, so I have to do it kind of more manually in this case.
What did you do?
I started the computer without the persistent drive, so it's no big deal. I can still do everything I need to do. I just have to be doing it a little bit differently.
It just takes a little bit longer.
Yeah, just a little bit here. See how it shows up, and we'll save it as loop initialize array. Okay, that's it. Now let's take a look at a different program to answer your question a little bit earlier. What if we would try to use an index of something that is not there? Okay, so we'll go ahead and create a new program just for that. line 1, let's see here. I can make this program really, really easy, okay? So we'll just say a bracket 3 gets a value of 5. Okay. That's the entire program. Because to illustrate the point that I want to illustrate, this is all it takes. And that will help us to really focus on the issue that we are trying to deal with instead of everything else. Okay. So in this case, I don't need comments because there are no conditions to evaluate. There's one single line, so I still need line number. I have, let's just say that I have a variable I before. I don't care what I use I for. I have array A. And let's just say that array A also has 3 elements, okay, 0, 1, and 2, which means a bracket 3 does not exist. And let's just say that we have some additional variables, x, y, z, and whatever. Okay? They're just here as to illustrate the concept. Okay. All right, so the precondition is, let's say we don't know anything about any variable. So they're all unknown as a precondition. So the question now is, after we execute line 1, or after we attempt to execute line 1, what is going to happen? Okay, now we all can kind of see there's a problem here, can't we? Because array A, which is displayed on as column C, D, and E. Okay, let me do the merge, so that we can emphasize the fact that they are all in the same box. Okay. Okay, there we go. So array A has 3 items. It has 3 elements: bracket 0, bracket 1, and bracket 2. No problem. But the statement on line 1 says, we want to look at element 3 inside array A and change that to 5. The question is, what is the program going to do? What?
Crash.
Well, that would be the best case, but it does not.
Would it update E4?
Okay, so to show this, to basically describe what the program is going to do, I will create 3 scenarios. So I'm going to copy the sheet twice so that we have 3 scenarios. So we'll do a copy, insert before, move to end position. We'll do it before sheet 3. The new name is, okay, we'll use this one for C and C++. The next one we'll use it for Visual Basic. And then we'll have one more, okay? So we'll have one more. And this is kind of like Perl, PHP, Python. Oh, doesn't like the slash. Okay. So now we have 3 scenarios. I'll have to rename sheet 2 to reflect what language we are dealing with here. So this is going to be C, C++. All right. Because they all respond differently. Okay. All right. So this is C and C++, which is the next class that you'll be taking. For most of you, you're going to take cisp300. So the behavior in this case is what you will be observing in your other class. That's what it's going to do. In other words, in C and C++, it will look at A and say, well, I know where A starts, okay? Because I know array A starts, at column C. When you say I want to change element 3, then it will count, okay, well, column C is A bracket 0, column D is A bracket 1, column E is A bracket 2, so column F has to be A bracket 3. Yep.
So it'll initialize whatever variable is listed after the container?
Initialize is one word, corrupt or clobber is the other word. Destroy.
Smash.
Smash. But unintentionally. In other words, it is not supposed to change variable x, but it does. Yep.
So it corrupts the next variable. What if there is no next variable? What if the in the code?
Then you're in even more trouble. Because if it is not a named variable next to it, then it is something more important. for bookkeeping and other purposes that you need to keep track of when you execute your program. Okay. In this class, I cannot really describe it at this point. By the time we get to subroutines, then we'll start to see what you may be corrupting or what you may be actually messing up. But at this point, we don't have those things yet. To truly understand the destructive nature of something that looks like this, you have to take cisp300, which is the assembly language programming class. Then you will actually get to see inside the memory layout of a computer program running C and C++, what is actually corrupted when you do something like this, what can be corrupted, and what are the effects of the corruption. In this case, the corruption can cause problems because you might be using variable x correctly somewhere else, otherwise, other than this code, you're using variable x for something. So suddenly, variable x has its own value changed suddenly by something that is not intentional. So the next time you refer to variable x, it's going to be 5 instead of whatever it was. And as a result, your program will behave differently. And when you look at, unless you know where to look, you won't even know that variable x now has a value that is unreasonable. Is everybody getting the idea? Okay, because this does not really show what the problem. But the issue is, variable x, this can be like one line of a 5,000 line program, right? Okay. The other 4,999 lines of code may be using x for one particular purpose or another, right? So when x has its original value accidentally changed to 5, the other 4,999 lines will use the new value of x instead of what it should have, to perform, the operation. And that can lead your program to the wrong path. But by the time the program, gives you signs that I'm in trouble, I'm not doing what I'm supposed to, do you know which variable to inspect to see that, oh, okay, this variable is not supposed to be this value? Because in a real programming environment, you don't have a trace. You cannot say, okay, here's a 20-page trace, and by the time the program is behaving incorrectly, it is over here, and I can go back in time and inspect every single value of every single variable during the execution. You don't have that tool. You just have a snapshot at the very end and say, oh, okay, x has this value at this point. But even so, you still have to say, out of the 20, 30, 100 variables that I have, how do you know that you have to look into x to find out whether that's the problem? And that's why this is a really, really serious issue, because you can clobber a variable accidentally, and by the time the symptom shows up, it's way too late. You cannot find out what is happening to your program. Yep.
Is column F, is that logically the number 3 column or not?
If array A had 4 elements, it would have used column F.
Okay.
And that's why in C and C++, it will just go ahead and use column F. And the reason has to do with in C and C++, during runtime or when you execute a program, the environment or the programming language cannot know the size of the array. Not natively. You have to do other things to explicitly represent and remember the size of an array. Yep.
If you were to do that with that sort of feedback after installing it the size of the array.
Sorry?
After you tell it the size of the array, would it say, hey, you can't do this, there's an error? Or would it
I don't think so. I don't think it would catch it. I don't think the compiler can catch that. All right, so this is in C and C++. Have I ever talked about the book called Leave a Rope Long Enough to Shoot Yourself in the Foot? Okay, that's one of the reasons. This is one of the main reasons why there are books like that. Okay, array indexing and pointers, 2 things. Okay, array indexing and pointers are the things that can be extremely powerful, flexible, and useful, but at the same time, they can be extremely dangerous as well. So when you're in cisp300, by the time you get to arrays and pointers, be very careful about your programs. Don't write a lot of code before you test it again, because you can run into problems that are very difficult to explain or even to find out what is going wrong with your program at that point. Okay, so that's one case, right? Because we got other cases. All right, so in Visual Basic, what it's going to do is it will do, when you attempt to execute line 1, Visual Basic will give you something that looks like this, okay? Array access out of bound, okay? In other words, it will pop a dialog box up on your screen saying that, okay, we have a problem, we are accessing the array out of bound on line blah, blah, blah of this program, which is the best response because it tells you exactly where the problem is when it happens. Instead of doing something it is not supposed to silently, and then by the time any problem shows up, it's like miles away from when it happened. Okay, so that's how Visual Basic is going to do it. It knows the size of the array. It knows that you're trying to access the array out of bound, and it just complains right away. It's like, okay, we're not supposed to do this. I don't know how to handle this. You deal with it.
That's a funny way to think of code. I can't handle this. You handle this.
Well, the computer can only do so much, right? Okay, now this is this is even more interesting in a way. Let me tie my shoelace before I fall flat on my face. There we go. All right. So in C and C++, the programming environment, which is an interpreter, also realizes that it will say, oh, array A currently only has element 0, 1, and 2, and you're trying to access an element that is not there yet. Okay. So Perl, being PHP and most scripting languages, will just do something like this. Like, oh, well, that's okay. I'll just go ahead and make that happen now. Oh, great. Okay, problem solved. Your array is now just 1 bigger than it used to be, but now element 3 does exist. Problem solved. Okay, and it will do it silently.
So it's okay if you intended to happen. It's not okay if you intended to assign that number to something else.
Okay, now I can, as a brain teaser, okay, this is not something that you have to do and turn in, but as a brain teaser, I want you to think about this. Okay, I want you to look at the program that we had a little bit earlier, okay, and look at this code here. What if I change the less than to less than or equal to? Knowing what C, C++ will do, knowing what VB will do, and knowing what Perl and PHP will do, think of this scenario, and in the next class, remind me to go over this so I can tell you exactly, in this context, what each programming environment will do.
The problem is, say, Perl or something like that, if your kernel size is too small for that variable.
It keeps making it bigger, so bar A bar keeps changing. Okay, so remember this, your brain teaser. We'll talk about it next time, next Tuesday. Have a nice weekend.
So we didn't take roll today?
No, I forgot to bring my roll sheet. It's okay, it's getting about that time that you start forgetting. Oh, thank you.